Hello, good afternoon, and thanks again for joining us at the Hannover Messe Hydrogen Fuel Cells Batteries Group Exhibit 2018. Please stay with us, have some drinks on the house. Our next talk will be with Professor Dr. Gunther Kolb, who's the head of Division Energy and Chemical Technology at the Fraunhofer-Institut for Microengineering and Microsystems, IMM. Thank you very much for joining us. Good afternoon. Hi. Thank
Hello.
you. Fantastic. So the topic today, I wanted to mention it, is called Fully Automated Fuel Processors and Complete Auxiliary Power Units for up to 50 kilowatts and beyond. And my first question would be that I understand that recently you were, the Institute went under recent changes and has become independent. Can you tell us about that?
So we had a transition period when we were coming to the Fraunhofer community, and we are an independent institute since the beginning of this year now. So Fraunhofer IMM.
Excellent. So it used to be independent, then it wasn't, and now
we
it
were
is again.
part of another institute for that transition period, yes.
Okay, now we're back. So again, the title of today is called Fully Automated Fuel Processors and Complete Auxiliary Power Units for up to 50 kilowatts and beyond. Can you tell us about that, and including automation?
So we're coming from the fuel processing side. So we are making hydrogen for fuel cells. That was our original business, let's say, making chemical reactors more in general, because this fuel processing means switching a series of chemical reactions after each other. So we can do everything which you need to build a fuel processor. We can make the catalysts by ourselves. We have own catalyst development facilities. We can fabricate the reactors, and we can put them together to hold fuel processors and test these fuel processors also. So now from that, we now want to get a little bit further on to full automation, not only of the fuel processors, but also of complete systems. So our biggest challenge this year is a 50 kilowatt system based upon natural gas, which we will link to a fuel cell and get the automation of that done. So a sort of demonstration of our capabilities.
And for your catalyst testing, are you doing it in-house, or does the catalyst testing take place elsewhere?
It's
you do it all together?
It's own catalyst development with testing and making own formulations. This is a big difference to most of the other groups working on fuel processing, which use catalysts from, let's say, generally from other sources.
And so can you tell us about your core technology, or tell us a bit more about your core technology?
So the institute is called Institute of Microengineering and Mikrotechnology. So we make everything which has small dimensions, at least inside. Such reactors which we are producing can be quite large, but they are very small channels inside. And we coat the channels with catalyst, which is very well utilized then. You don't need much catalyst because of that. And actually we build plate heat exchangers out of it. So we can combine chemical reactions, we can cool chemical reactions very efficiently, we can supply heat to them depending on the reaction, and arranging that in stacks of plates where exothermic, endothermic reaction taking place, we are getting very compact devices. And then, I mentioned a little bit of that before already, we have the manufacturing capabilities also. So it's not only that we make prototypes, we can help you to introduce these devices later on into the market, also in larger numbers. Small channels can be made very cheaply by embossing of metal plates. We know that from fuel cell technology as well. We can screen print the catalyst into the small channels. You can stack the plates up, I said that, up to several hundred of these plates, and by that make a plate heat exchanger out of it, which is really fabricated very cheaply and sealed by laser welding, also with a welding speed of maybe up to 15 meters per minute. You can build such devices which are very well sealed and very compact.
Thank you. What other applications do you have as far as residential or mobile, or what is it that you have?
Of course, when we are talking about 50 kilowatt, this is more a stationary application, but we have many applications in the field of mobile, partially for vehicles, but also for aerospace applications. We are currently working together with the company Deal Aerospace on an energy trolley for passenger planes, where we use propylene glycol. Nobody else uses propylene glycol. Maybe it sounds strange, but it's not toxic. When it's mixed with water, it's not burning. So it's an attractive fuel to run it in a plane. And we built such an energy trolley as a first step. We want to make power supply for the kitchens of the plane, for the galleys.
Yes, we were mentioning before that it's in planes, in fact, that a lot of energy goes to the kitchen, which is not something that people would think about. So that's quite useful and quite interesting. And going a little bit away from that and more about your building, I understand you recently had a building expansion.
Yeah, I told about this 50 kilowatt system. We will be put into a containerized environment. And our vision is also we get a new building, which doubles almost the size of our institute, with a large technical hall where we can put such containers in and prepare them for our customers for different types of applications. That can be power generation from natural gas or ethanol, but it can be also production of chemicals for chemical industry, decentralized production. So there are many other applications for such kind of containers. For example, fuel synthesis. You can take renewable sources where you don't want to transport the renewable biomass to the production plant. You do it more decentralized and get synthetic fuels out of it. For example, synthetic gasoline. So we are currently running such a containerized plant for production of gasoline out of wood residue. So many other applications we also can use that new building for.
Thank you. And you were saying before in our pre-talk that you can in fact build everything. The building is so large, so you can build everything in one package and just bring it all out together, rather than going through a trouble of one by one and putting it together elsewhere. So that's great. What areas of opportunity can you talk to us about? Perhaps I hear something about medical devices that you were also working on?
Yeah, the Institute generally works on a large variety of applications which use microfabrication as the core competence. Yeah? So we make also mixing devices for chemical industry. By that you can produce chemicals with a much better efficiency and a higher selectivity. But we also work in the field of medical analysis instruments and other equipment for on-site analysis. For example, the patient goes to the doctor, he gets directly an analysis which normally takes a week to get the result back. That can be very interesting and sometimes even save lives. Yeah? We have made electrodes for the spinal in case there is a break of the nerves, you can even bridge these things. And we got one patient a few years ago, which could walk again through the use of such a kind of electrode. So there are many other applications we can look at with our technology. And the common thing is the small dimensions, which you sometimes don't see from outside.
Thank you. And we're nearly the end of our talk here. What would you like people to take away from our conversation today as far as the Institute goes?
As we are here on the stand for hydrogen and fuel cells, the most important message is that we can produce reformers cheaply with a novel fabrication technology for a large variety of fuels and with production techniques which are well suited for mass production.
And now we're talking about the 50 kilowatt
Yes.
challenge here. Well, thank you very much for joining us. The Fraunhofer-Institut for Microengineering and Microsystems, IMM, is actually in booth B74, which is just sort of kitty corner from us. And so our thanks to Professor Dr. Gunther Kolb, head of the Division Energy and Chemical Technology. Thank you very much. Thanks. Please stick around with us. Our next guest will be Dr. Simon Board, who's the CTO at ITM Power. And the topic will be hydrogen for refinery applications, building the world's largest PM electrolyzer. Thank you very much.